Hello students, today we are going to discuss about Cohen Sutherland line clipping. Now, this particular line clipping algorithm basically treats analytical line clipping against a rectangle, right? So this particular rectangle is considered to be the display window. What is a display window? The display window is basically a viewing area of a computer display screen. That is what it is, right? So what is the objective of this particular algorithm? The main objective of this algorithm is to clip those lines which are crossing the rectangle, which are passing through the rectangle, right? So if I consider a line which starts from this point and ends at this point, then the part which is exceeding, or the section of the line which is exceeding the rectangle boundary has to be clipped off, and the portion of the line which is inside this particular display window should be only displayed to the corresponding application user or application level of user, right? So in order to do this particular thing, what we do is that we have to first see whether the line is trivially accepted or not. That means, what does that mean? Whether the particular line is lying within this particular rectangle window or not. If a line basically exists, or if a line is lying inside this particular rectangle, then there is no question of running Cohen Sutherland line clipping algorithm, because the line is already inside the rectangle viewing area. But if the line crosses the rectangle viewing area, then obviously we have to clip the section of that particular line which is outside the rectangle boundary, right? So for that, first of all, what we need to understand is that if the line is not inside the rectangle, if the line is not lying inside the particular rectangle, then what we need to do is that we have to find the region codes of the line. That means if a line starts from here and the line ends over here, then this particular line has a part which exceeds the rectangle boundary, right? So in such a case, when the line has exceeded the rectangle boundary, or when the line has exceeded the rectangle boundary, then we have to find the region codes of the particular line. So region codes, so to calculate the region out codes, what are the different rules that we are going to consider, that we are going to see first, right? So the first thing first is, first we consider a rectangle which is a display window, that is already been said, and now what we do is that we extend the rectangle boundary into these sections: above, right, below, left. All the sections of the rectangle are extended, right? Now we have marked some labeling over here. We have done some labeling. What are those labeling? This is X mean. X mean means if I consider this has to be the X-axis and this has to be the Y-axis, then this particular line this particular line is labeled as X mean, and this is labeled as X max. What is this X mean, X max? This is the rectangle dimension, right? The rectangle dimension, this particular rectangle, this side of the rectangle is basically coming on the X-axis. This is the X mean of the rectangle boundary. This is the X max of the rectangle boundary, right? So this is the Y max of the rectangle boundary. This is the Y mean of the rectangle boundary. So the entire boundary lines are being marked as X mean, X max, Y mean, and Y max, which cover the entire rectangle boundary, right? So now in the middle of this particular rectangle, I have written a value 0, 0, 0, 0. What is this particular code? So this is basically termed as region out code, and this particular code has a certain formula of forming it. What is that formula? We will know it first, right? So the basic formula behind forming this particular code is to follow a rule which is A, B, R, L, right? What is this A, B, R, L? A means above, B means below, R means right, and L means left. If I consider the first bit to be the MSB bit of this particular number sequence, then the first bit is for above, the second bit is for the lower or the below, the third bit is for the right, and the last bit is for the left one. After we know the full form of ABRL, now what we do is that we have to see what this above, below, right, left are actually. The above is with respect to y max, the below is with respect to y mean, the right is with respect to x max, and the left is with respect to x mean, right? So if I try now, in order to basically calculate the region codes for the remaining areas, we are going to take the help of the rule that we have set over here, right? So first what we do is that we'll start solving the region out code for this particular section. So if I start with this, then the first bit, which is the MSB bit, we have to check whether this particular section is above y max or not. We are checking whether this particular section is above y max or not. If it is not true, we put a 0. If it is true, we put a 1, right? So since it is not above the y max, so we put a 0 over here, right? So now next what? Whether this particular section is below y min or not. Yes, it is. So we put a 1 over here, right? Now next, whether this particular section is to the right of x max or not. It is not to the right of x max. So what we do is that we put a 0 over here, right? And now we check whether this particular section is to the left of x mean or not. No, it is not. So we put a 0 over here, right? So now what we do is that we solve for this one. So in this particular case, again, whether this particular section is above y max, no, it is not. Whether it is below y mean, yes, it is. Whether it is right of x max, yes, it is. And whether it is left of x mean, no, it is not. Right? I hope you're understanding what I'm trying to mean. So now we go for this section. Whether this particular section is above y max, no, it is not. Whether it's below y mean, yes, it is. Whether it is right of x max, no, it is not. Whether it's right, left of x mean, yes, it is. Right? So we have already computed or calculated the code for this particular section. Now we move on to this particular section. So this particular section, whether it's above y max, no, it is not. Whether it's below y mean, no, it is not. Whether it's to the right of x max, yes, it is. Whether it's left of x mean, no, it is not. Right? So now we move on to this part. Whether it's above y max, yes, it is. Whether it's below y mean, no. Right of x max, yes. Left of x mean, no. Right? So now this one. Above y max, yes. Below y mean, no. Right to x max, no. Left to x mean, no. Right? So now for this one. Above y max, yes. Below y mean, no. Right to x max, no. Left to x mean, yes. Last one. Above y max, no. Below y mean, no. Right of x max, no. Left of x mean, yes. So in this way, we have solved or we have calculated the region codes for all the remaining sections using the rule that we have set as ABRL. Now, what we do is that we will take different cases of lines that can pass through the rectangle, and we will see that how we are actually detecting whether a particular line lies inside the rectangle boundary or whether it is crossing the rectangle boundary, and we need to trim those line sections which are exceeding the rectangle boundary, how these particular sections are being treated. Now we will understand those particular sections. Okay, now what we do is that we have taken some lines which are crossing through rectangle, some which are not even touching the rectangle, and some which are inside the rectangle itself, right? So we have decided to label those lines as P1, P2, P3, P4, P5, P6, P7, P8, and P9, P10. These labelings are the endpoints of a particular line, right? So now we will see that what is the visibility of each and individual line that we have considered in this particular section. So first, to start with P1 and P2, which is this particular line. So this line is completely out of the rectangle region, right? So obviously we will write that this line is rejected. Right? So if this is rejected, Then next one is P3, P4. P3, P4 is inside completely, right? So there is no requirement because this particular line has not crossed the rectangle boundary, right? So if it has not crossed the rectangle boundary, then obviously it does not require any kind of Cohen Sutherland like sort of line clipping algorithm. So obviously it will be trivially accepted. Now we come to P5 and P6. So in case of P5 and P6, a section of the line remains inside the rectangle and a large section of the line remains outside the rectangle. So this particular line needs to be, or such lines need some calculations to be done so that the section of the line which is outside the rectangle boundary can be trimmed off, and the section which is left off is the one that is inside the display window. How it has to be done, we will come to that part. So in this particular case, P5, P6, it is partially visible. Right? Now we move on to P7, P8. Again, in the case of P7, P8, we see in P5, P6, one of the particular endpoint was outside the rectangle boundary, but in case of P7, P8, both the endpoints are outside the rectangle boundary. So obviously we have to trim this part, trim also this part, and the remaining part which is inside the rectangle boundary can only be displayed in the window display screen. So again, this particular line is also partially visible. Right? Now the last one, P9 and P10. Again, P9 and P10 is not at all touching the rectangle boundary, or it has not even crossed the rectangle boundary. So obviously it is rejected. Right. So now when we are talking about rejection or trivially acceptance, or we are talking about partial visible, all such kind of conditions are, or with all such conditions we have listed out, is basically by seeing those lines, right? So how do we actually find the logic so that this particular logic will do the same work that we are actually doing over here? So what is that logic? So the logic is very clear. The logic is, first we'll go with the P1 and P2, right? So for the P1 and P2, if you see it carefully, then for P1 and P2, what are the different outputs or region outputs? We will first calculate that, right? So for P1, the region output should be, it is greater than Y max, it is not below Y mean, it is not to the right of X max, but it is to the left of X mean. So obviously it will be 1, 0, 0, 1, right? So this particular section has a code of 1, 0, 0, 1. What is for P2? This is not above Y max. This is below Y mean, right? So we'll write P2 over here and write 0 because it is not above Y max. It is to the below of Y mean. It is not to the right of X max, but to the left of X mean, right? So this is what we get. Now, if I see carefully this particular two region outputs, and if I try to perform a logical AND, operation between these two binary streams, then what we get is this. That means what? We are not getting a value of 1. All the lines which are not even touching the boundary of the rectangle, or it is not going through the rectangle, will all have its corresponding logical AND operation as a non-zero value. So all the ones which are partially visible or which are completely inside the rectangle boundary will have their logical AND operation as complete 0. We will see that one by one. We consider another one which is completely outside the rectangle boundary, which is P9 and P10, and we try to compute P9 and P10, right? So for P9, the region output is greater than Y max. Yes, it is. It's below Y mean. No, it is not. It is to the right of X max. Yes, it is. It is to the left of X mean. No. For P10C, if it is greater than, if this one is greater than Y max. No, it is not. Less than Y mean. Yes, it is. Right of X max. Yes, it is. Left of X mean. No, it is not. Right. So in this particular case, see, again, if you perform a logical AND, then you have 0, 1, 0, 0. So again, it comes out to be a not equal to 0, right? It is not a 0 value. So obviously we then understand that these two lines are completely outside the rectangle boundary, and we simply reject those lines. This is the main logic, right? So if you see carefully about these two lines, you see that there is a bit position in both the endpoints which are having a common one, right? If they are having a same one in a particular column, or in a particular column of these two encodes, whatever the whichever wherever the line it is, if a certain column has a 1 in both the region outcodes of both the endpoints of a line, then obviously the logical AND operation of such a line cannot be equal to 0. And in these two cases, it is because of this particular case only. So obviously we will not accept these two lines. So what about these two or these three lines? What are these three lines talking? So we'll see that first. So I'm just rubbing this section now. So we'll now take the example of P3 and P4, right? So for P3 and P4, what is the case? Let's see. So for P3, we calculate the region outcode, since it is inside the rectangle, so it is all zeros, and P4 is also inside the rectangle, so it's all zeros, and we perform a logical AND operation. I'm sorry. So if I perform logical AND operation, I will get all zeros, and it is inside the rectangle. Obviously it is, right? So how to understand whether this particular line is trivially accepted and we do not have to run a Cohen Sutherland line algorithm, I will come to that part. But what I'm trying to explain is that how do we understand whether we have to accept a certain line or we have to reject a certain line. That is the main logic behind this logical AND operation. Since P3 and P4 are completely inside the rectangle, this particular line requires no kind of trimming. It is trivially accepted. How to understand the trivial acceptance, that has a separate logic. But before that, we are actually trying to understand whether we have to accept this particular line or we have to reject the line. Yes, we have to accept it because the logical AND operation of the two endpoints region codes is equal to 0, and if it is equal to 0, then only we will accept that particular line, right? So now we come to P5 and P6. So if I take P5 and P6, then for P5, the corresponding outcode or region outcode will be greater than y max. Yes, it is. So it's 1. Less than y min, no. Right to the x max, no. Left to the x min, yes. So it is the region outcode. And for P6, it is all zeros. So you understand, if one of the endpoint is inside the rectangle, obviously the outcome will be all zeros, because the endpoint which is inside the rectangle has a region outcode of all zeros. So if one of the endpoint is all zeros, and if you perform a logical AND operation, the output will be always a 0. So now for this one, P7 and P8, in which both the endpoints are not inside the rectangle, but the line goes across, or the line crosses the rectangle, right? So what about this? So for P7, the region outcode will be, it is greater than y max, it is less than y, it is greater than y max, yes it is less than y min, no, it is greater than x max, no, it is less than x min, no. So it will be only 1 triple 0, right? Now for P8, it is greater than y max, no, less than y min, yes, greater than x max, no, less than y min, no. So it is only having 1 in the second bit and all are zeros, right? So this is what we have. And if I perform a logical AND operation, since there are no columns which are having a 1 in both the region outputs of the two endpoints, so the corresponding output of the logical AND of these two one is also zeros. So we understand that P3, P4, P5, P6 and P7, P8 are the lines which are going to be considered to be a part of the display system, and the lines P1 and P1, P2 and P9, P10 will not be considered or will be rejected in that case, right? So now we come to the next part, is that how do we understand whether this P3, P4 will not be required, or this P3, P4 is basically a line which has to be trivially accepted P5, P6 and P7, P8 are not the ones which can be trivially accepted, because we need to run the line clipping algorithm. So P7, P8 and P5, P6 are the one which are partially visible, and the P3, P4 is the one which has to be trivially accepted. Now what we do is that before performing the logical AND operation, if we perform a logical OR operation between these two, and if we see the outcome is all zeros in the logical OR operation as well, then we understand that the line is obviously inside the line will be accepted. Obviously it cannot be rejected, and also this line is trivially accepted. So if we go with P3, P4, then before actually we perform the logical AND operation, if we perform the logical OR also, then also these two lines will give the output as zeros, because there are no ones in this particular case. But in P5, P6 and P7, P8, there has to be at least a single one. If a line crosses the rectangle boundary, like P7, P8, it crosses the rectangle boundary, then both the endpoints will have at least a 1 in the 4 bits of the region code. It has to be, right? And in case of P3, P4, in the 4 bit of the region outputs, since P3 and P4 both are lying inside the rectangle region, so obviously there can be no ones in the particular region codes. And if you perform a logical OR operation before logical AND operation, then we get a 0, then we understand that particular line requires no kind of trimming. But in case of P5, P6, before performing the logical AND, if we have performed the logical OR, obviously the logical OR output will be 1 0 0 1. This is the OR operation, right? This is the OR output. And if I consider this one, then this one will be 1 1 0 0. This is also the OR operation output. So if I perform the logical OR before the logical AND operation, then we get a non-zero value. That means this particular line is not to be trivially accepted. Then we move on to the AND operation. But in this particular case, since logical OR operation has given a value 0, we will not perform a logical AND operation, because from the logical OR operation it is clear that there requires no kind of trimming algorithm to be run on this particular line, and so we do not move into the Cohen Sutherland line algorithm, and before moving that we actually trivially accept this particular line. So in this way we actually perform, or we actually understand which line is inside the rectangle boundary, which is outside the rectangle boundary, which has to be trivially accepted, which has to be completely rejected. Now what we do is that we'll understand how to actually trim the lines into the rectangle boundary if one of the endpoints or both the endpoints actually crosses the rectangle boundary. Now what we do is that we take an example to solve a kind of line which has crossed the rectangle, boundary, and we have to trim off that part of the line segment which has crossed the rectangle boundary. In this particular example, if you see that the rectangle boundary is having its dimension in the x mean as -2, x max as 2, y mean as 2, and y max as 4, right? And we have considered a line AB where A endpoint is at just the boundary of the rectangle, and B is crossing the rectangle boundary to this particular end location. Now, first, what we have to do is that we have to understand we have to know the coordinate location of A and B. The coordinate location of A is 1, 2, 1, 2, and the coordinate location of B is -2, 5, right? So now what we have to do is that we have to first find out the region outcodes of these two endpoints. So in order to calculate the region outcode, I'm writing region outcode as ROC. So I'm trying to find out the region outcode of ROC of A endpoint. So A endpoint, since it is just at the boundary of the rectangle display system, so it will be all zeros. Obviously, you can understand that if one of the endpoint is all zeros, then the logical AND operation of this one has to be all zeros. So after that, we calculate the value of or region outcode of B. And if we calculate, then we have to calculate this one. D is lying above Y max. Yes, it is. D is lying below Y mean. No, it is not. It is crossing X max. No, it is not. It is crossing X mean. Is it less than X mean? No, it is at the boundary of X mean. So it is not less than X mean. So it is 0, right? So if I just do a logical AND operation, then we'll understand whether this particular line is acceptable or not. So I have already told in my example previously, or in my video previously also, that when we are going to calculate the logical AND, before that we have to understand whether this particular line is trivially accepted or not. For trivial acceptance test, we'll do or we'll perform a logical OR. If we perform logical OR, obviously we are not going to get a zero value, which means that this particular line does not have both of its endpoint inside the rectangle boundary. So now we move on to the logical AND operation, and if we perform the logical AND operation, we see that we get all zeros. If we perform logical AND operation, right? If we perform logical AND operation, we get all zeros over here, and if we get all zeros, then we know that this particular line is partially visible. That means a part of the line has crossed the rectangular display system, and we have to apply the Cohen Sutherland line clipping algorithm. Now, in order to understand that which part has crossed, that means I want to say whether both the endpoints have crossed the rectangle boundary system, or whether one of them has crossed the rectangle boundary system. That we have to understand, or we have to check it first. So it is very easy to understand. So what we do is that we check whether A is having a region output all zeros or not. If it is all zeros, then that means that yes, A is inside the boundary, or A is inside the rectangular boundary. And if D is equal to 0 or not. If D is not equal to 0, that means D has crossed the rectangular boundary. But if the example, or if the line was such that both A and D were outside the rectangular boundary, then if we keep a check that whether A is equal to 0 or not, then A is not equal to 0, that means A is also outside the rectangular boundary, and D is also not equal to 0, that means D is also outside the rectangular boundary. That means first we have to take the A coordinate, or the A endpoint, and trim off the line which is outside the rectangular boundary. Then we will move on to the D endpoint, trim off the line which is outside the rectangular boundary, and the resultant line which is left out is the one which is present inside the rectangular boundary. But in our case, since A is inside the rectangular boundary, so obviously it is 0, so we are not concerned with A, we'll move out to D. So when we move out to D, we have to find the point of intersection at this particular point. So in order to find the point of intersection, what we need to do is that we need to understand the formula of actually forming this. I'm naming it as x comma y. Right. So if I name it as x comma y, I will change something over here, but later, right now I'm not changing anything. I'm just writing x comma y. Right. So what we do next is we have to understand how to find the point of intersection. This particular section will be covered using a mathematical formula which is known by the term as point slope form of line equation. What is that particular thing? That means what we are supplied is we are supplied with the A coordinate location, we are supplied with D coordinate location, and we know how to calculate the slope of this particular line. When we are given both the endpoints, then we can easily calculate the slope of the line. The slope of the line can be calculated as y2 minus y1 divided by x2 minus x1. If I consider A endpoint is having a coordinate location of x1 comma y1, and D coordinate is having a coordinate location of x2 comma y2, then obviously the slope of the line can be easily calculated as y2 minus y1 divided by x2 minus x1. So when we have calculated the slope of the line, now what is given to us? See, out of these two endpoints, D is outside the rectangular boundary, right? So the coordinate location that we are really concerned with is D, because from the D coordinate location, the line that is started from D coordinate location is the one that has to be trimmed off, right? So what we are supplied is we are supplied with the D coordinate location. We know the slope of the line. Now we have to find the equation of the line, right? When we find the equation of the line, being supplied the D coordinate location and the slope of the line, if we put the value of x comma y into this equation of the line that we will calculate, then we can easily find the point of intersection at this particular point. Now the next question could be that what is the value of x comma y? And if I know the value of x comma y, then why I am calculating the equation of the line? That's the reason behind this is because at this particular point, you know one of the coordinate location, you don't know the other coordinate location. You know what is y, you don't know what is x, because this D point has crossed the y max boundary, or we can say that the D endpoint has exceeded y max. So if you're going to trim that D point, then it has to come down to y max, right? It has crossed the above the y max location. So if I need to trim off, then it has to come down to y max, right? It has to come down to y max. So I know what is the value of y, because it will come down to y max, because y max is the upper dimension of this particular rectangular window. So if I know the value of y, which is equals to y max, which is equal to 4 of the dimension of the rectangular window system, then what I need to do is that I just need to calculate the value of x. So if I know the value of y, then if I put the value of y in the equation of the line that will be calculated, then easily I can get the value of x, right? So this is what the trick is. So what we do is that we have to understand that how we are going to do that, right? So after we have calculated the slope of the line using y2 minus y1 divided by x2 minus x1, then we are supplied with the b coordinate location and the slope of the line m. Now, using these two given entries, we have to calculate the equation of the line. And if I assume that the point of intersection of this particular point is x comma y max, right? Because it will be trimmed down to y max, then how to form the line equation of the line? The line of the equation will then be, I will first again find this slope of the line with these 2 points given. I will find the slope of the line, and then I will try to form the equation of the line from there. So what it is that y minus, so what I do is that I will consider this point as x2 comma y2. So y minus y2 divided by x minus x2, right? So this is what y minus y2 divided by x minus x2. So in this particular case, the y is basically the y max, right? So what we need to do is that we need to find the value of x. So what we'll do is x minus x2 will then be equals to 1 by m into y max minus y2, right? So then x will be equals to x2 plus 1 by m into y max minus y2. So this is the equation, or this is the value of x, and the value of y is y max. So now what we have understood, or what we have done, or whatever equations that we have written over here are all written with respect to x0. What is this x0? We have considered the point x0, y0 as to be the endpoint of that particular, or the coordinate location of that endpoint from where the line has to be trimmed off. Among these two endpoints, these one of the endpoint from where the line has to be trimmed off. So what we do is that we assign the value of x2 comma y2 to another coordinate location x0 comma y0, which is the coordinate, or which are the two variables, x0 and y0 are the two variables which are now responsible to trim the line off which is outside the rectangular boundary. That means what I'm trying to say is that just we have to do is that we have to replace x2 with x0 and y2 with y0. And if I do this particular thing, then what we get is x equals to x0 plus 1 by m y max minus y0, and y will be equals to y max. So if this is the one, then see, since this has crossed the above, since D has crossed the y max boundary, so if you go with this particular above means which has crossed the y max boundary, see the equation is exactly the one that we have formed over here. X equal to x0 plus y 1 by m y max minus y0, and y is equal to y max. I hope you have understood what is x0 comma y0. The x0 comma y0 is the one which has the coordinate location of that endpoint from where the line has to be trimmed off. In this particular example, since A is inside the rectangular boundary, so A will not be assigned to x0, y0. So D is outside the rectangular boundary. So D will be considered to be as x0, y0. That means we have just put x2, that means we have just done x0 equals to x2 and y0 equals to y2. This only has been done and nothing else has been done. That's why what we have done is that we have put x2 in place of x2 we have put x0, and in place of y2 we have put y0. So in this way we are going to find out the equation of the line x. In a similar way, if this particular point was not here, it was here outside the rectangular boundary below y min, again what we know is that if I need to trim, if the line was in this fashion, right? If the line was like this, right? If the line was like this, then if this is outside the rectangular boundary, then we know that we have to trim this off to this particular coordinate location. Again, this particular coordinate location, the value of x is again not known to me, but the value of y is known to me. And what is that value of y? This is y mean. So when it will be crossing the y mean below, we are going to follow this below formula. That means the same formula has to be applied. In the place of y max, we will put y mean. So in place of y max, we have put y mean, y max, y mean, right? So if it was not above and below, it will be either right or left. If the line is crossing like this, right? If the line is crossing like this, so if I take the x max first, then I need to trim this line from this particular point to this particular point, right? This is the point where I need to trim it off. So again, in this case, we don't know the value of y, we know the value of x because it is to the boundary of the rectangle system, and this boundary has to be x max. So obviously in that particular case, from this m equal to y max minus y2 x minus x2, we have to find the value of y, right? We have to find the value of y. We won't be finding the value of x. So what we will do in that case is, what we'll do is that we'll put x max minus x2. So this will be the only change, right? So instead of putting y equal to y max, we'll put x equals to x max, and now find the value of y from this particular equation. And since we are again interested in putting the endpoint which is under consideration from where the line has to be trimmed off, that particular endpoint has to be put in x0, y0. See, when right one is the one which has crossed x max, is having y equal to y0 plus m into, if I calculate this particular formula, I will show you how is it being done. I will show you. So if I consider this line, okay, this horizontal line. So if I take this point to be as A and this point to be as D. So again, we will be having a value of x2, y2, and if I want to trim this particular line off, then this particular line will be trimmed off to this point of intersection, and this point of intersection has a value of x is equal to x max, but we don't know the value of y. So again, we know what is the slope of the line. So slope of the line again will be calculated using y2 minus y1 divided by x2 minus x1. After that, what we need to do is that we are supplied with d coordinate location and the slope of the line, and we have to find the point of intersection. So if I name it again as x comma y, since x is equal to x max, so we rename it as x max comma y, right? So the equation of the line will then be m equals to y minus y2 divided by x max minus x2. So from this equation, we know that we have to find the value of y. So that will be equals to y2 plus m into x max minus x2. Since again, I've already told x0 and y0 are the two variables which are responsible in taking up the coordinate location of that endpoint for which the trimming of the line, from where the trimming of the line is going to be performed. In this particular case, D is the one from where the trimming of the line has to be performed. So the coordinate location of D will be assigned to x0, y0. That means again, x2 will be assigned to x0, y2 will be assigned to y0. So what we do is that we replace y2 with y0 and x2 with x0. So we will get as y0 plus m into x max minus x0, and the x value will then be equals to x max. So if you look into the right, which is this one, see y equal to y0 plus m into x max minus x0, and x equals to x max. In the case of left also, you have to just replace x max, because in this particular case, the x coordinate location will come down to this particular point, which is the value of x mean, and we don't know the value of y. We have to calculate the value of y. So instead of putting x equals to x max, we'll put x equals to x mean, and the remaining equation will be all the same. Instead of putting x max, we'll put x mean. That's it. So in our example, we don't have all the different kinds of cases. We have the above or this particular one as the example in our case. So what we do is that we try to calculate what is the trim of line or what is the trim of part. So now, after we do this, we will first, what we do is that we assign x0 to be the coordinate location of D, right? So what is D? This is the D point. So D is having an x0 value of -2 and y0 to be as 5. So this particular point is -2, 5. Now what we have to do is that we have to put this particular value in this case, right? So before that, we'll calculate the value of m. So what is m? Y2 minus y1 divided by x2 minus x1, which is y2 minus y1 means this is x1 y1, this is x1, this is y1, this is x2, this is y2, right? So y2 minus y1, 5 minus 2 is 3, which is -3, right? This is what we get, right? So this is what we get. So in this case, the m is equal to -1, right? So now what we do is that when we get the value of m equal to -1, I'm just rubbing this off. When we get m equal to -1, now we are supplied with this coordinate location and the slope of the line. We have to calculate the equation of the line using this particular formula. So x will be equals to x0 plus 1 by m into y max minus y0, and y will be equals to y max. So what is this? X equals to x0 means -2 plus of 1 by -1. So already 1 by the slope of the line is -1. So instead of putting anything, we'll put just -1. Y max is what? Y max, the value of y max is 4. So 4 minus 5. This is what we get. And so x will be equals to -2 plus of 4 minus 5 is -1. -1 into -1 gives you +1. So this gives you as -1. So x will be as -1. So what is the coordinate location of x comma y now? So the coordinate location of x comma y is -1 comma y max is 4. So -1 comma 4. So see the value of x comma y max. So this is x comma. So x comma y max is -1 comma 4. See the point of intersection over here has a value of x equals to -1, and obviously the value of y max is 4. So the D point is shifted down to here, and we name it as D prime, and this is the trimmed off line. So the line so this particular point has shifted from this section to this section, and the line is trimmed off. So in this way, we actually perform the trimming of line using Cohen Sutherland line clipping algorithm. I hope that you understand this particular way of implementation. I will appreciate if you try some more different cases of lines and apply the same Cohen Sutherland line algorithm. And if you find any problem, please let me know in the comments, and don't forget to subscribe my channel and like and share with your friends. Thank you.